barely on. See that door over there, and I can see like up on the stage. Can you kind of see this door a little bit? Because it's still an exit that needs to be monitored. This door? Yeah.
No, we couldn't.
No.
We need another camera.
Well, I'm being the security guard. Yeah. At all times?
No.
Or just at the beginning?
Started,
Okay,
yes.
okay.
You'll have to let me know.
Okay.
Now people, ooh, that was very fast. Thank you very much. Can you all hear me okay? That's good. I like being loud. This is perfect. So, I want to welcome you all here today. Yay! Students, as you look around, you're going to see lots of people here, and they are all wonderful helpers here for you today. And first of things, I want you guys to give a big round of applause to thank them for coming. Wonderful supportive parents here with us today. We have your teachers, of course. And we also at the back, if you all turn your head and look back there, you can see Mr. Tim Prater. He is all right. Very good, very good. So, what we are doing today, I know that students have already seen a lot of the videos, but we are doing a science experiment that is going to try to break the record for the Guinness Book of World Records.
Mr. Healy, please contact the office. Mr. Healy.
So, we are going to do this. We are going to start exactly at 1 o'clock, and all over Canada, all the way from St. John's to Victoria to Nunavut and Yukon, we have different schools coming together to do the exact same experiment that we are doing. So that is really, really cool, and I'm super excited. I can barely sleep last night. Anyone else? No? So I want to show you a video that is a welcome from one of our Canadian astronauts. So if you could just look at the screen, that would be fun.
You can't see anything.
On October 12th, you are invited to host a world record in Fund of Science. Science.bc.ca and partners across Canada are organizing an event for a new world record for most people taking part in the science experiment. Through experiments, we're able to validate existing theories, discover brand new ways of seeing things, and increase our understanding of how the world works. And sometimes what seems like an experiment gone wrong can lead to great discoveries that change our lives forever, like the discovery of penicillin. Later this year, I'll be blasting to space on a Russian rocket to reach the International Space Station, a huge orbiting laboratory. And during my 6-month mission, my crew and I will be performing over 100 science experiments on behalf of Canadian and international scientists. I hope that you can be part of this world record event. Join thousands of Canadians across the country. Have fun and learn.
All right, and now we have another guest that just arrived, and they're going to come out and say hi to you, so give a warm welcome to Mayor Dizak, please.
Are you guys ready? Today, you guys get to make history. It's not every day that you get to be a part of a world record, and it's not every day that myself and my favorite MPP, Kim Prater, get to witness one. So we're really excited, and I just want to say, on behalf of City Council, on behalf of all the residents of Niagara Falls and everyone around the world that are going to take part in watching you guys be a part of history, I want to say congratulations. Thank you very much.
I just quickly want to say to the students in particular, I had the pleasure of being up front collecting the tickets when you came in. I asked you all to wave to the camera, and I saw some great smiles. Everyone waved. But more importantly, just as the mayor said, when I got an email from Kimberly asking me if I would come out, like many of you have done, the parents and the teachers, I didn't hesitate at all. So for the kids, this is really cool. I have never, in all the years I've been in politics, been ever asked to be a witness for a Guinness Book of Records attempt. So I want to say thank you, and anything we can do. We'll fill out the forms properly, but our goal is to get you into the Guinness Book of Records with the mayor and myself. So it's a pleasure to be here. Have fun.
Our time is quickly coming up. It looks like we have 1 minute to go until we are going to start. Okay. And we are going to start, we have to start with a signal. So when you hear the whistle, this is when we're going to start timing our timekeepers. And when we hear it again at the very end, this is when we're going to stop our timing. Okay. And then once we start, your groups are going to go quickly to grab your supplies on the table and come back. So wait for my signal. 1, 2 minutes for each.
Okay, hold it in front of the camera. Good. Yeah, you can see that was perfect.
Careful. Hands under your head at the front. Perfect. That looks great. Now for step number 2, what we're going to do here is we are going to take, we're going to wash the dumbbell. We're going to take her lovely piece of string, fold it in half, and then she is going to snip right in the middle, so she now has 2 pieces of string. Okay. So everybody, take your string, fold it in half, cut it in 2, thumbs up when you're finished.
They're in the way of the stage. Mario, can you have them leave? Thank you.
Our next step, you're going to tie a piece of string to each balloon, but make sure it's nice and long so we can dangle it, just like Madame Waddell is going to show you up here. Your materials are all ready now. So now we're going to start working through our steps of how we're going to do our experiment. But I want you just to watch first and see how it's done. And then you're going to write your hypothesis after you see how we set it up. And the hypothesis is your best scientific guess of what you think is going to happen. So first, Madame Waddell is going to hold the balloons up by hand about the same level as her head. Right? So her balloon, her head is like the same height as the balloon, right? And then the balloons are going to be nice and still, they're not moving. And then finally she is going to softly blow between the balloons. But before she does, I want you guys to talk in your group for 1 minute to see what you think is going to happen. Hypotheses, I'm not sure I'm French. So what we're going to do is we're going to watch Madame Waddell and we're going to see what happens. Wow. Okay, you see that? The balloons, did they go together? Did that happen? Those balloons just kissed, right? That's okay. So what happened there, my hypothesis wasn't that. I thought when we grew, we were going to blow the balloons in all directions. But it didn't. They went together. So I want you guys to try that in your group. You're going to hold up your balloons. What? All right, go for it.
ahead of y'all first.
So everybody has a turn. All right, good. Now it is time. A part of our scientific process is that we must take observations. So we want to write down what you saw, and if you're not sure, then I want you to make sure you try it again and write down exactly what you're seeing if you haven't already. Let me give you 1 minute to jot down all the stuff you saw happen when you do it. Right now, I'm going to explain the science behind what you just saw. Okay? I'm going to explain exactly why that happened. So, this is a balloon. We know this. And even though you don't see it, there is actually air all around the balloon, and it's pushing on all the sides of it. Do you believe me? Yeah. Right. Teachers never lie, so always believe your teachers. So here we go. We have all this air pressure around the balloon pushing on it. And you know what? When this balloon's still, it means that all the air is pushing with the exact same amount of force. So the air that's pushing on this side is just the same as the air pushing on this side, so it's not moving anywhere. Does that make sense? Right. But the reason that air pressure is actually caused because air it's heavy, it has weight to it. So that actually is the weight of the air holding your balloon like that. So it's standing still. But the pressure is nice and equal, but what happens is when we have the two balloons and we're blowing, we're actually causing a decrease in pressure somewhere. So if I decrease the pressure on this side, that means that this side is weaker than the other side. And the other side pushes it where it wants it to go. So when you're seeing your two balloons, like this, and you're blowing between it, you're causing low pressure here, so the outsides are powerful and they shove them together until they kiss. But there's actually a reason that this is happening, and it is called Bernoulli's principle. And what it says is that when we blow, we're making air move. And when the air starts to speed up, the velocity of the air around the balloon is actually causing it to be low pressure. So when the air velocity increases, pressure decreases. Now, I know what you're thinking. I'm sure this is exactly what you're thinking. You're thinking, but Madame Clausen, when I blow, why is the air going around the balloon? Why isn't it going straight out? Well, that's a great question. Thank you for asking. So, what it is when you blow, there's actually something called the Coanda effect. That's not on the test, just remember what it means. So Coanda effect means that when there's a stream of something moving, and that it actually really likes to stick to an object and follow it all the way around. So because we're blowing it likes to stick to the balloon. It wraps around, causing the airspeed to speed up. And in the center, there's low pressure. And then all of a sudden, they kiss. But don't be alarmed because the balloons are married, okay? So that is all right. So I want you guys, that was our first experiment, and it is finished. We are heading on our second. So balloons, please. I want you to get them out of your reach and they're no longer in your hands. So put them to the side. Wow, that was great. You guys are even smarter than I thought. You guys are doing awesome. So we are ready for our next experiment. This one is super cool, and it's called the water mixture. For this, your materials, make sure you have them in front of you, are 1 cup, 1 straw per student. So every student is going to need their own straw. And you're going to need scissors and your ruler. Okay, if you do not, if you're missing any of those things, please put your hand in the air and then Wilson will come give them to you. Okay. Excellent. All right, so let's get started with our procedure. What are we going to do with this? So, the first thing we're going to do, and I want you to quietly do it, after you see her do it, I want you to quietly do it in your group. That way we can go through it a little bit quicker. So she's going to open the bottle. You twist like this. Perfect, excellent, I've seen it happen. Then you're going to pour it into your cup until it's 3/4 full. So you're going to have like this much space with no water at the top of your cup, okay? So, and then, it's very important, put the lid back on your bottle so you don't kick it over, please. So you may go do that now. Fill up your cup 3/4 of the lid. Thank you. So your next step is going to be, you're going to need to take your straw, and you're going to take your ruler, and you're going to measure 10 centimeters, just about that much, and then at 10 centimeter mark, you're going to snip it. So cut it with your scissors. So you should have 2 straws, one 10 centimeters, and the other one's going to be just a little bit shorter, it's going to be around 7 centimeters. Hands on your head when you're done. You guys are speedy, very good. All right. All right. Next up, here it is. You guys need to make sure you're watching the video without me this one. This time, she is actually going to pick up the shorter, not the water, but the short of the straw. Okay, not the long one, the short one. And she's going to put it in her glass of water. So the bottom of the straw is actually in the water, okay? You should be able to hold it though. Don't let it go. Make sure you're holding it there. And then, don't start it yet, just watch for now. But everyone else going to take her second straw, the longer straw. And she's going to put them so they're forearm just barely touching it. Just a little bit of overlap. And then she's going to blow a quick, short breath, but she's actually not going to, because first I'm going to give you 30 seconds to make your hypothesis. What would happen when she blows? We're glad you're excited about science, but we need to make sure we stay on time. And as my class knows, I'm not good at staying on time. So we need to make sure we get through this here. So you're going to watch and actually see what happens first, because this is what should happen. As you will notice, there is water misting out the end of the straw. This is a really good hint. I'm going to give you some good advice here. Do not aim it at people in your group. So make sure there's a little bit of overlap there. And also make sure to write down your observations. All right, now go for it, Brandon.
Oh my God, you're right.
Yes, work.
best explanation of the science there. You're going to notice that when the water is in the cup, it's actually standing still, right? That water is not going to move unless something disturbs it. So unless I shake the cup or poke it, or a dinosaur from Jurassic Park walks by, that thing is not going to move, okay? So it just stays there. Make sense? But even when you insert your straw into the thing, you can actually barely see it move. It adjusts that quick because there are forces acting on this cup. There is stuff that we can't see. There is air pressure pushing down the water, and there's gravity. So that's why it's staying there. So there is pressure pushing on our water. And when we create low pressure over top of our straw, what happens is, it's like when you're pushing down all the water with the pressure, and there's no pressure here, so it shoots up. It's kind of like what happens when you step on like a ketchup packet, and the ketchup shoots right up. All your pressure went down, so it had to go up. So the way we did that was we actually created, by putting the two straws together, this one was blowing into this one a little bit, right? So because of the geometry of this again, so both experiments have to do with the shape, so it caused the air to follow the straw right along into the cup where it pushed down, and because of that, the air speed sped up, and that's why it blows so hard. If you guys were blowing soft, you could see the water move up and down the straw, but if you blew hard enough, all of a sudden you created enough airspeed that went fast enough that the pressure became low enough on top of the straw that it could rocket out the mist on people. So that is what we call the Bernoulli effect. Can everyone say Bernoulli effect? Excellent, very good. So that was our final experiment. I can tell you one more thing about this guy Bernoulli. His real name was Danny, so I'm going to call him Danny. And that's his first name. He created this. He was a Swiss scientist. And actually, he's super famous because this principle that we've been working on today is actually used for airplanes. And that's the reason why they can actually fly, is because of this pressure thing he figured out. So that is very cool. So one more thing, our science experiment now is going to be over. So our timer, if you could go over to the camera and click them off for us. We will end our signal.
Good.
Now. Good. Very good. So what we need to do as scientists, the first thing, because you're nice scientists, you're going to thank all the members of your group. I want you to shake hands and thank your fellow scientists. Need a round of applause one last time for all the wonderful people that came up to help us today. Thank you. We actually need to sit down. We need one more thing to get us through the whole virus thing from us is they need us to be sitting so they can have a nice shot of all of our heads and they can count exactly how many students are in the room right now. So all students, if you guys can be sitting in your sections, and our lovely photographers can they're really good at being really, really neat and tidy. So, first things first, your group needs to make sure you have all of your names on your observation sheet. And then you're going to keep sitting